Dear learners, welcome to the session on data structure. This is Dr. Fathima presenting you. First of all, let me tell you why you are supposed to study data structure. So let me tell you the problem of finding or searching a given number available in a set of data. Assume that the given set of data is 2, 9, 16, 35, 43, 56, 78, 81 and 94. In this, the problem is to search for the number 9, 78 and 97. So tell me what is the solution to find out whether the number is available or not. Generally, we have the solution as to search sequentially. It is called as linear search. Now tell me what is the number of comparison you do to find out the number 9 is available in the list or not. Yes, for case 1, that is for the number 9, the number of comparison required is 2 to find the result that the number is available. For case number 2, that is number 78, it requires 7 comparisons to give the result that the number 78 is available in the list. For case number 3, that is the number 97, it requires 9 comparisons to give the result that the number is not available in the list. Let me give you the alternative solution to find that the number is available in the list or not. Again, we'll consider the same set of data and the numbers to be searched will also the same. Now my solution is find the mid element, compare with the given number to be searched. If it is less, then the number will be in the left half, else the given number will be in the right half. So we will continue with the same process until we get the result. Now for case 1, that is for the number 9, the mid element is 43. So the number 9 is compared with 43. Since the number 9 is less than 43, then we will proceed with the search before the number 43, that is in the left half. So we will repeat the same process now again with the left half. The middle element is 9 and the number 9 is compared with this element in 9. Now since their match is found, we will stop the iteration and the number of comparisons required to give the result is 2 in this case. Now consider the case 2 of finding the number 78. Again we apply the same algorithm of finding the middle element. The middle element is 43 and the 43 is compared with 78. Since 78 is greater than 43, the number may be available in the right half. So we repeat the same iterative process with the right half. So again we will continue to find the mid element. So the mid element is 78 in this right half and the 78 is compared with the given element, that is 78. So since both are equal, the match is found and the result is displayed, the match is found, that is the number is available in the list by 2 comparison. Now consider the case 3 with the number 97. Here again we apply the same algorithm of finding the middle element. So that is 43. Since 97 is greater than 43, we have to proceed with the right half. Again finding the middle element in the right half. So the number 78 is compared again with 97. Since 97 is greater than 78, we will do the comparison in the right half. So among this 81 and 94, again the middle element will be 81. So 81 is compared with 97. Since 97 is greater, again we will proceed with the right half. So the last element we have 94. So 94 compared with 97. So 97 should be the right half of 94, but there are no other elements. So we will stop the iteration and the number of comparisons made is 4. So let us compare the number of comparisons made with the traditional search and the alternative search. So for the given example, for the number 9, the traditional search requires 2 comparisons, similarly the alternative search. And if you see the number 78, the traditional search requires 7 and the alternative search requires 2 comparisons. 97, for 97, the traditional search requires 9 comparisons and the alternative search requires 4 comparisons. Totally put together, suppose I have a problem of finding all these 3 numbers even in a given set of 9 numbers. So I require at most 18 comparisons in the traditional search, but the alternative search I require 8 comparisons. By this you can identify that how the alternative search has reduced the number of comparisons, by which the processing time will also be less. So this alternative solution I have given you is nothing but the binary search algorithm, and data structure that is used to apply this binary search algorithm is binary search tree. So the knowledge of data structure and the algorithm is required for reducing the processing time. So I conclude that you need data structures and algorithm to solve the problems efficiently. To solve the real-world complex problems efficiently, you need to learn data structure. The other reason to learn data structure is to crack the interviews, especially the placement. Most of the product-based companies, they test questions in the data structure. Now let us see what you learn in the course data structure. So if you come across the syllabus of this data structure, we have linear data structure, that is list, covered in the first unit, where the list types and the applications are seen. In unit 2, the linear data structure, stacks and queues are discussed along with the application. In unit 3, nonlinear data structure, trees are discussed, where binary trees, traversals, binary search tree, AVL trees, heaps, binary heaps, binomial queues are discussed. In nonlinear data structure, graphs is discussed in unit 4, and where we will see the graphs, the algorithms, applications of graphs. Unit 5 covers the searching, sorting and hashing techniques. Let me tell you the introduction. What is data? Data is nothing but the values or set of values of different data types such as int, float, char, boolean, etc. Then what is structure? It is nothing but the way of organizing and storing information so that it is easy to use. Now, what is data structures? Then it is nothing but a combination of data and structure, that is the way of organizing and storing data on a computer so that it can be used easily and effectively. I can put it in another way. Data structure is a representation of data and the operations allowed on that data. Now let us see what is abstract data type. It is nothing but a mathematical model together with the various operations defined on that model. It stores the data and allows various operations on the data to access and change it. It is also called as a collection of data and associated operations for manipulating the data. So if you see that ADT, it provides a way to add an item, remove an item, find, retrieve or access an item. There are other possibilities like finding whether the collection is empty or full, or making the collection empty, or extracting a subset of collection. Here I have given you the example of ADT array. So you all know that ADT array is a collection of elements of same data type, and the elements are in an array is stored in an adjacent memory location, and the syntax is you will be specifying the data type, array name and the size, and here the example is int array A of size 50, and the operation that can be performed in this ADT is insertion, deletion and the search. So here the ADT is nothing but the mathematical model int A50, and the operations are the insertion, deletion and search. Together it called as the abstract data type. So the abstract data type will mention only the what are the operations to be performed, but it will not specify how they will be implemented. Thus, ADT is a specification of the data type and doesn't depend on the independent of the implementation. Then how this data structure and the data type are connected? Data structure is the physical implementation of the ADT. The data structures used in the implementations are provided in a language, that is, either it can be in a primitive type or as a built-in type. So this Python is an example where some data structures are available as a built-in type. Whereas in C, if you see that there are data structures like list, stacks and queues has to be defined by the user. So in data structure, each operation associated with the ADT is implemented by one or more subroutines in the implementation. Now let us see the classification of data structure. The data structure can be classified as primitive and non-primitive. Further, the primitive data types are int, char, float, boolean. Now coming to the non-primitive data types, again it can be classified as linear data structure and non-linear data structure. Arrays, linked lists, stacks and queues come under the category of linear data structure. Trees, graphs and hash tables come under the category of non-linear data structure. Here I have given you the visualization of the various data structure which we have discussed now. Next is the selection of the data structure. So whatever the data structure types we have seen so far, that is, there is no single data structure that works well for all the purposes. So it is important to understand what are the data structures that are available, what are the strengths and what are the limitations of these data structure in order to apply the right data structure to the right application. The choice of particular data model depends on the two considerations, that is, it must be rich enough in structure to represent the relationship between the data elements, and the structure should be simple enough that one can effectively process the data when necessary. So with this,